Designated router priority is the topic of this video clip. But before we talk about that, let's see what would happen if, let's say, there are 4 routers connected on the same subnet 10.1.1.0 with the address of a host 1, 2, 3, and 4. Each one of them has a loopback interface, and we know that OSPF is going to pick loopback interface as its router ID when it's starting as a first choice if there is no router ID manual command. So we know what those IDs are going to be. But let's think what's going to happen with the relationships. So they will start sending hello packets and starting presenting their IDs in the hello. Once they see each other, they will establish two-way relationship. But because this is a broadcast segment, broadcast network elects designator and backup designator router. Let's see what happens by default, and we already know that. So the highest router ID is going to be selected, the DR, if more or less they happen to establish adjacency at the same time. So that's going to be 4444. That's going to be our DR. The second highest router ID is going to be elected as a BDR, so that would be the role of R3. That will make R1 and R2 druthers, DR others in OSPF. However, we know that the exchange of LSAs by now is only done via, on the broadcast network, via multicast address 224006. So if R1 is to advertise anything, it is going to be using 224006 rather than 224005 on, let's say, point-to-point network. So that is going to be advertised towards DR, BDR, and we know that the DR, which would be R4 in our case, would be distributing that information using 224005 to everybody else once. Now, when that thing is happening, let's observe how we can influence the DR election after it was done, because initially we can affect that using the router interface priority in OSPF. By default, priority value is 1 on each of those E00 interface. This could be a tiebreaker, but only if they are just starting to see each other. They're starting to create this adjacency. Once the DR has been elected, it's irrelevant. The priority, just like a router ID, new ID comes in with the highest priority or highest router ID. It doesn't matter. We already have DR, we already have BDR. So there's a way of changing that on the production system, but it'll be a little bit more difficult afterwards. So let's see that happen. First of all, I'm going to quickly create a configuration for all my routers in a text editor. So here I'm going to say what I need really is conft router OSPF process 1. I'll use network statement. Let's just say 10.0.0.0, so it will just run OSPF on any interface starting with 10. And I'm gonna disregard the remaining bytes of the interface address, and I'm gonna place them all in area 0. So all interfaces E00 right now will be, I could do this also this way because it's a 24-bit mask, so I could go 10.1.1. In that case, I would need to modify my wildcard mask to this. Either way, the end game is going to be, or end result is going to be the same. Now, once it's done, I will just wait for 40 seconds because it's going to take 40 seconds for the routers to actually establish adjacency on the broadcast network. There's this interface wait timer. They need to decide if there is a DR or BDR already present before something happens. So I'm going to copy that, go to my router 1, paste it in, router 2, paste it in. So it's more or less the same time. 40 seconds time interval is waiting time anyways here, so I should be good to go. So in 40 seconds time, I'm going to see, we can minimize that adjacency is going to be built. And there's one more thing I need to show you before we finish that video clip, and that relates to the adjacency built and how they see each other, because there's going to be one surprising thing, I think, in this design in terms of the adjacency, and we'll explain why that is. So let's see what just happened now. Let's see who is the DR BDR in our case. In our case, the DR and BDR will be elected based on the highest interface OSPF priority. If they are all the same, the highest router ID, and that's the default, highest router ID wins. Let's see what happens here. I'll do show IP OSPF interface E00 on R4 first. And I will see that myself is in a DR other state. So this interface is DR other. The designated router is 1111 and backup designated router is 2222. Now, how did it happen if this is the highest ID of the router in place? What must be happening here? This router 1 must have the highest router ID priority ID on the interface. Priority by default is value 1. So if we just narrow down this output maybe to, it's actually showing here, we can always narrow this output to show IP OSPF interface E00 include priority. It'll show us the state and the priority. So this is DR other and the priority is 1. So if I jump to R1 and I'll do the same thing, show IP OSPF interface E00, let's go for full output, and what we'll see here is that our ID is 1111. Our priority is 255 because I made it manually on the interface and state is DR. That's why it became DR even though its router ID is not the highest. So show run interface E00, this is what I have added to the configuration to make that happen. And 254 is on R2. So if I do the same thing, it's a backup by designated router, show IP OSPF interface E00. There we go. This is the router ID. It knows that the designated router is 1. I am the backup designated router. My priority is 254. That's why I'm BDR. R3 and R4 have defaults. So their state is drother, priority is 1. Now this is because it happened on all devices at the same time. If, however, I remove that interface E00, no IP OSPF priority 255, it goes back to default. It doesn't matter at this point because priority is not preemptive. So it only changes when there's a re-election happening. So I'm going to do this once here. So I'm going to remove the priority from here. Do show run interface E00. Interface E00, no IP OSPF priority 254. Goes back to defaults. Now it's still the same situation. R1 is still DR, R2 is still backup DR. If, however, I'm going to do this, I'm going to clear IP OSPF process, and I'm going to do this on all devices at the same time. And I'm going to confirm that more or less the same time. So it's asking me a question, are you sure? Now, because this is disrupted, everything is going to be broken. If the routing was working, it won't work for 40 seconds now. So I'll say, yes here, yes here, I want to, yes here, and yes here. So what I'm doing is I'm re-establishing adjacency, so it takes another 40 seconds to elect the DR, BDR, and synchronize databases. So obviously it is a disruptive system. There's a way of doing this in a non-disruptive manner. So at this point, because I did remove the priorities from R1, R2, R4 should be our DR, BDR. Let's see that happen. So my R4 should have 3 adjacencies, show IP OSPF neighbor, and they are, since there are 4 routers, 3 is BDR, 2 and 1 are druthers, I must be DR, and show IP OSPF interface E00. The state is DR. even though the priority is identical on all of those, R4 was elected DR because of the highest router ID. Now, what if I wanted to change it in a less disruptive manner? So the only way to do this is by making the changes on R1, R2. So let's go back to those changes again. I'm going to go quickly, interface E00, IP OSPF priority, let's say 255, so the highest possible. By the way, if I do priority, there's one thing we need to mention. The priority 0 makes this device ineligible of becoming DR BDR, and that's what I'm going to use to release R4 and R3 from their roles. So if this is now priority 255, nothing changed though. Except priority is enabled, but nothing changed in terms of the state. The R1 is still Druther because it's non-preemptive. It won't affect anything after the election. So I'm gonna go here, make it interface E00 IP OSPF priority 254, second highest. Now how do I make them actually now DR and BDR? So one way we've seen is to clear the process on all of those, but that's very disruptive and stops the traffic for 40 seconds. Maybe less disruptive way of doing that. So I'm still Druther here. I can make now R3 this interface and R4 this interface ineligible of becoming DR BDR. Let's see that happen. So I need to quickly jump to R3 and R4. Let's just maybe clear the terminal so we can see this better. What I'm going to do is I'm going to jump to the interface on both, conf t interface E00, and do show IP OSPF interface E00 include priority. So it's still BDR. I'm going to do the same thing on R4. So conf t interface E00 do show IP OSPF interface E00 include priority. So now we have DR. So how to get rid of that? So the only way now, without disrupting or clearing the process on all of those at the same time, is to make R3 and R4 ineligible for a moment to become DR BDR. If I do that, let's say, I'll say IP OSPF priority 0. So what's going to happen when I hit enter? Well, what's going to happen? R3 is going to become DR. Now, why is that? Even though there's a higher priority, it's because it's a backup. So backup assumes the role of DR if DR is no longer there. So clearly we see right now it's BDR. If I hit enter now, and I repeat this on R3, let's just give him a moment. Now it's DR. Now, even though the highest priority is now on R1, because backup assumes its role now. It's non-preemptive. So if I do the same command, IP OSPF priority 0 on this one, now the real action is going to happen between R1 and R2. So let's go here. Let's show its state Druther. So is now our R4. So at this point, R1 should already be DR. Show IP OSPF interface E00 includes priority. And sure enough, it is. So once it is, now this one is BDR, show IP OSPF interface E00 includes priority. It is BDR, so now I can remove those commands and bring the factory default. So I'll say no IP OSPF priority. It'll become Druther. If that's the case, state Druther. Here the same thing, no IP OSPF priority. Check the state, it's Druther, all good. One last thing. So R1 is now fully adjacent with everybody else. So is BDR. R2, show IP OSPF neighbor. Well, one last thing I want to see is what's the state between Druther to Druther. So everybody is associating themselves with the DR BDR, including themselves, and they're fully adjacent. But what is the state between R3 and R4, Druther to Druther? So here, show IP OSPF neighbor. It's two-way. So between an R3 and R4, the state is two-way. Is that a problem? No, it's not. It's just the way they communicate now. They see each other, they see their router IDs in hello receiving from the partner, but they're not fully adjacent because they build adjacency only with the DR and BDR on the broadcast segment. So if there's 4 or more routers, old routers will only be two-way. If, let's say, however, one of them is going down and new one is elected, there's only 3 left, between them, R2 and R3 and R4 will need to have now BDR elected if R1 is down. And obviously that's going to be, again, priority first. If the priority is not there, the highest router ID wins, so backup would become R4. Then R3 will be fully adjacent with the R2 DR, R2 DR, and R3, R4 BDR. But between routers, two-way state is normal. That's the way it should be. So that concludes that video clip.